You know, there are some things in math that just feel, well, kind of elegant.
Yeah.
And prime numbers, they're definitely like that. They
Yeah.
seem so simple, right?
Mm-hmm.
Divisible only by 1 themselves.
Yeah.
But at the same time, they hold these crazy mysteries, unsolved mysteries that have baffled, like, mathematicians for centuries.
It's true.
Yeah.
Prime numbers are like, they're like the atoms of math.
Yeah.
The fundamental building blocks of all other numbers.
Yeah.
I-
But we still haven't cracked the code of how they work.
We haven't cracked the code.
Their hidden structure. And that's where the Riemann hypothesis comes in, right?
Exactly.
This idea that there's a secret pattern to how these prime numbers are sprinkled throughout all numbers.
Yeah.
Like, imagine if the key to cybersecurity or to understanding the universe
Right.
was hidden within these seemingly random numbers.
It's a wild thought.
That's what we're diving into today.
You've hit the nail on the head.
Okay.
The Riemann hypothesis, it basically attempts to predict where on the number line
Okay.
these prime numbers will show up.
So you're looking for...
It's like trying to find
Yeah.
a hidden message
Okay.
in what seems like random static.
Okay, so let's break this down a bit.
Sure.
I've heard that the Riemann hypothesis is notoriously difficult to grasp,
It's fair.
even for mathematicians.
Yeah.
So can you give us the explain it to me like I'm 5 version?
Okay, so imagine a perfectly straight line, okay?
Okay.
And this line represents all numbers, right?
Gotcha.
Now, imagine throwing darts at this line, but the darts can only land on prime numbers.
Okay.
The Riemann hypothesis says that there's a specific pattern
Mm-hmm.
to where these darts will cluster.
Interesting.
So there's a kind of hidden order to this seemingly random distribution.
So it's not just about knowing which numbers are prime,
No.
but understanding like the underlying structure
Yes.
of how they're arranged.
And the visual representation of this problem, believe it or not,
Okay.
is a fractal.
Okay, now I know we've thrown around the term fractal a bit,
Sure.
but for those of you who don't have like a poster of the Mandelbrot set on their wall,
Right.
can you give us a quick refresher
Absolutely.
on what a fractal is?
A fractal is a never-ending pattern,
Okay.
a shape that repeats itself at different scales.
Okay.
So think of a snowflake. Each tiny branch of a snowflake looks like a miniature version of the whole snowflake itself.
Yeah, that makes sense.
That's the beauty of fractals.
yeah.
Infinite complexity,
Hmm.
but arising from these simple rules.
So the visual representation of this incredibly complex math problem, the
Yeah.
Riemann hypothesis, is itself this mind-blowingly beautiful and intricate pattern.
It is.
That's pretty wild.
And what we're looking at today is how researchers are using AI
Okay.
and even a bit of quantum computing to try and crack this code.
Wow.
We're talking about actual Python code that combines these advanced concepts to understand the Riemann hypothesis.
Now, this is where it starts to feel like we're stepping into a sci-fi movie a little bit.
A little bit, yeah.
Python code, AI, quantum computing.
Yeah, it's cutting edge stuff.
It sounds incredibly complicated.
But at its core,
Yeah.
it's all about using these powerful tools to understand something fundamental about numbers.
So let's talk about this code.
Yeah.
What does it actually do?
In essence, the code attempts to approximate a mathematical function
Okay.
called the Riemann zeta function,
Mm-hmm.
which is kind of like the Rosetta Stone to understanding the Riemann hypothesis.
Okay.
It uses a combination of traditional mathematical methods and something called quantum correction
Okay.
to get a more accurate understanding of how this function behaves.
Okay, I have to admit, quantum correction sounds a bit intimidating.
Yeah, I can see that.
Can you walk us through that part?
You're right, it sounds complicated, but it's actually quite elegant.
Okay.
The code simulates how a quantum computer might work
Right.
to refine our understanding of the Riemann zeta function.
So quantum computers, I mean,
You see, they operate on the principles of quantum mechanics,
right, which is different than how we normally think about things.
which is a completely different way of looking at the world compared to, like, classical physics.
So it's like using a super-powered magnifying glass
Yeah.
to look at this Riemann zeta function
Precisely.
in a way we never could before.
And this quantum correction, it allows the code to explore solutions that would be impossible to reach
Oh,
using traditional computers.
okay.
And here's the really cool part. The output isn't just a bunch of numbers.
Don't tell me it generates another fractal.
It does.
You're kidding.
The code creates a stunning 3D visualization of the problem,
Wow.
a fractal that evolves and changes as the AI learns.
Okay, hold on. The AI is learning. So it's not just crunching numbers. It's actually trying to figure out the pattern.
You got it.
Wow.
The code uses a form of artificial intelligence called machine learning,
Right.
which you might have heard of.
Yeah.
It's the same technology used for things like image recognition
Yeah.
and predicting what you'll buy online.
Yeah, exactly.
But here, we're using it to try and unlock one of the biggest mysteries in mathematics.
So let me get this straight. We're using AI,
Yes.
inspired by quantum mechanics,
Yes.
to visually represent a complex mathematical problem as a
Same.
constantly evolving fractal, all to try and understand the hidden structure of prime numbers.
That's the gist of it.
This is blowing my mind, and I thought prime numbers were just something I learned about in middle school.
It's a whole other level.
This is light years beyond that.
It really is.
Wow.
And what makes this even more exciting is that this approach, using AI to tackle mathematical problems,
Right.
it's still in its infancy.
Wow.
We're just starting to explore its potential.
So what you're saying is we're potentially on the verge of a whole new way of doing mathematics.
That's what's so exciting about it.
This is huge, but
Yeah.
before we get ahead of ourselves,
Sure.
let's break down why this matters.
Okay.
We've talked about the Riemann hypothesis being important.
Yeah.
But what are the real-world implications here?
That's a great question.
Yeah.
And it leads us to some really fascinating possibilities.
Wow.
Well, the Riemann hypothesis, it's not just some abstract mathematical puzzle,
Right.
like tucked away in a textbook,
Yeah.
If it's proven true, it could have massive implications for things that affect us, like every single day.
Okay, now you've got my attention.
Okay.
Give me an example. What kind of real-world stuff are we talking about?
Let's start with cybersecurity. Right now, your online banking, your private messages, all sorts of sensitive data
Right.
are protected using encryption that relies on the unpredictable nature of prime numbers.
Hold on. So I'm trying to connect the dots here.
Okay.
Are you saying that our current level of online security depends on prime numbers being, well, mysterious?
Exactly. It's like trying to fit a key into a lock.
Okay.
Only the right sequence of prime numbers unlocks the encryption and allows access to the data.
Okay.
But if this code, if this code helps us crack the Riemann hypothesis and we uncover that hidden pattern in prime numbers,
Yeah.
it could completely revolutionize how we secure information in the digital age.
So we're talking about potentially needing to rethink cybersecurity entirely.
Yeah.
That's a pretty big deal.
It is, but it's not just about security.
Okay.
The implications go way beyond that.
Okay.
Remember, prime numbers, they're the building blocks of all numbers, right?
Right.
So understanding their fundamental structure could change how we approach mathematics
Okay.
as a whole.
So walk me through that.
Okay.
What would it mean to understand the deeper structure of math?
Okay, imagine you're an explorer
Okay.
and you've stumbled upon a hidden map.
Okay.
Now, this map, it doesn't just show you new lands.
Yeah.
It reveals a hidden order to the world you thought you knew. That's what proving the Riemann hypothesis could do for mathematics.
Wow.
It could unveil this deeper elegance and order to numbers, to like the very fabric of reality itself.
Whoa.
You see what I'm saying?
Now that's getting pretty profound.
Yeah.
We're talking about potentially changing our understanding of
Yeah.
the fundamental laws of the universe here,
It's a big thought.
just from studying these prime numbers.
It might sound unbelievable,
Yeah.
but that's the power of fundamental mathematics.
Okay.
Discovering a hidden structure in something as basic as prime numbers could have ripple effects across countless fields,
Wow.
from physics and cosmology
Yeah.
to computer science and engineering.
Okay, so I have to ask,
Yeah.
are we close? Is this code going to be the thing that finally cracks the Riemann hypothesis wide open?
That's the million-dollar question. Right?
Right.
And unfortunately, there's no easy answer.
Okay.
We need to temper our excitement with a bit of realism here.
Okay.
The Riemann hypothesis, it's incredibly complex.
Right.
This code, while groundbreaking, is just one piece
Okay.
of a much larger puzzle.
So even if it doesn't solve the Riemann hypothesis outright,
Right.
what does this research tell us?
Right.
Where does it fit into the grand scheme of things?
That's a great point.
Yeah.
Even if it doesn't hand us the solution, on a silver platter,
Right.
this research is still invaluable.
Okay.
Think of it like shining a new kind of light on an old mystery.
I like that analogy.
Yeah.
So it's less about finding like the final answer
Yeah.
and more about illuminating new paths,
Exactly.
new ways of looking at the problem.
It might not give us all the answers,
Yeah.
but it will certainly spark new questions.
Right.
reveal new insights and potentially lead us down paths we never even considered before.
And that's what makes this so incredibly exciting.
It is.
It's not just about prime numbers. It's
Right.
about pushing the boundaries of what we know and how we understand the world around us, really.
You said it.
Yeah.
And who knows what other seemingly impossible problems
Right.
we might be able to tackle
Yeah.
with this kind of outside-the-box thinking and innovative technology,
Absolutely. It really is like we're standing at the edge of the unknown. And this research is our flashlight, kind of illuminating the path forward.
A very powerful flashlight.
Yeah.
Powered by, artificial intelligence and quantum mechanics.
Exactly.
Yeah.
It makes you wonder what else is out there
Yeah.
waiting to be discovered,
Right.
right? If we can just find the right tools
Right.
and ask the right questions.
Exactly.
And that brings us back to the Riemann hypothesis.
Yeah.
We've talked about its potential impact on cybersecurity, mathematics, even our understanding of the universe. But for you personally,
Right.
what is the most mind-blowing possibility if this hypothesis turns out to be true?
For me, it goes back to that idea of hidden elegance, right?
Yeah.
The idea that these seemingly random prime numbers, these fundamental building blocks of mathematics, might actually hold like a deeper meaning.
Okay.
It's like a secret message woven into the fabric of reality itself.
Wow.
That's a truly awe-inspiring thought.
It's like the universe is whispering to us
Yeah.
through these numbers, and we're finally starting to listen.
I love that.
And,
Yeah.
for anyone listening who's feeling a little overwhelmed right now,
Sure.
trust me, I get it.
Yeah.
We've covered a lot of ground today.
We have.
But here's the thing to remember.
Okay.
You don't need a PhD in mathematics to appreciate the beauty and the mystery of this stuff.
That's right.
Just the fact that we're asking these questions, that we're using cutting-edge technology to unravel these ancient mathematical secrets.
Yeah.
That's pretty amazing.
I couldn't agree more. It's this sense of curiosity, this drive to explore the unknown
Right.
that really pushes humanity forward.
I love that.
And who knows what other incredible discoveries await us just beyond the horizon.
Well said.
Thank you.
So the next time you see a prime number, don't just see a number.
Yeah.
Think about the secrets it might hold,
Yeah.
the mysteries it might unlock.
It's exciting.
Because out there, somewhere in the vast expanse of numbers,
Yeah.
the answer to the Riemann hypothesis is waiting.
It's out there.
And maybe, just maybe, it's waiting for someone like you to discover it.
You never know.
That's all the time we have for today's deep dive.
Okay.
But remember, the exploration doesn't stop here.
Right.
Keep asking questions.
Yeah.
Keep learning, and keep your mind open to the infinite possibilities of the universe.
Well said.
Until next time.
See you next time.